Welcome to HBOT Journal, a channel dedicated to understanding hyperbaric oxygen therapy through evidence, science, and experience.
Oxygen, right? It's the stuff we connect with life itself. We breathe it every single moment, never even think about it. It just feels passive, harmless, and totally fundamental. But you know that familiarity? It can be really misleading. Because in a medical context, the whole nature of oxygen changes completely. It stops being just air and becomes something that demands precision, restraint, and a whole lot of respect. So, that leads us to the big question for this whole explainer. What actually happens when the air we breathe crosses this invisible threshold and becomes a medicine? The moment oxygen gets concentrated, stored, or delivered on purpose, it completely transforms from just being in the background to something that has to be actively managed with a totally different set of rules. Let's dig into what that transformation really means.
Okay, so here's how we're going to break this down. First, we'll look at that jump from air to medicine. Then we'll tackle the two very different kinds of risk, the environmental limit, which is fire, and the biological limit, which is toxicity. After that, we'll get into the logic behind all the safety controls, and finally, we'll see how it all clicks together into a complete system of safety.
All right, let's start right there at that crucial moment, the point where oxygen crosses the threshold from just being a part of our atmosphere to becoming a controlled medical substance. Seriously, understanding this one shift is the key to everything else.
And this really shows you the fundamental difference, right? On one side, you've got background air. It's about 21% oxygen, and our relationship with it is totally passive. But on the other side, you have medical gas. It's concentrated, and every single thing about it, its pressure, its flow, how long you're exposed to it, is actively managed. Look, this isn't just about more oxygen. It's a totally different classification.
So here's the bottom line, the official definition. A medical gas is any substance, and that includes oxygen, that's no longer just a passive part of the environment. The second you start intentionally controlling it, it demands this whole system of oversight, because everything about it, its behavior, its risks, it all changes.
Okay, so we've established that oxygen is a managed medicine. Now let's get into the first major risk that comes with that label, the external environmental danger that, let's be honest, most of us have heard about but maybe don't fully understand, and that's fire.
And this is probably the single most important aha moment to have when it comes to oxygen safety. Oxygen is not flammable. It won't catch fire by itself. What it does is act as an accelerant. It supports combustion, which means it makes other things burn way more easily and much, much hotter. That distinction is absolutely critical.
You know, we've all probably seen the fire triangle at some point. You need fuel, heat, and oxygen. Now, in a normal room, that oxygen component is pretty stable and predictable. But when you're in an oxygen-enriched environment, that leg of the triangle gets, well, supercharged. The exact same fuel and the exact same heat source will now act in a completely different way because the oxygen has completely changed the rules of the game.
And that's exactly why ignition sources are controlled so carefully. Think about a tiny spark from static electricity, say, from a synthetic shirt, something you'd barely even notice in a regular room. In an oxygen-rich space, that tiny spark can become a major ignition source. The spark itself is the same, but the world it's burned into is totally different.
Okay, but fire, that's an external thing, right? It's an environmental risk. There's a whole other category of risk to think about when you're using medical oxygen, and this one is internal. It's biological, toxicity.
So let's put these two risks side by side, because they are completely different. Fire risk is external. It's about how oxygen interacts with materials and the environment. Toxicity, though, is internal. It's a biological process that's all about the dose your body gets over time. And you have to manage them with totally different sets of rules.
So what is oxygen toxicity anyway? Well, it's not some sudden event like a fire. It's a physiological response that can happen when the body is exposed to high concentrations of oxygen for too long. I mean, our bodies are built for the 21% oxygen in the air. When you change that balance in a big way, it can start to disrupt normal cellular function.
So, managing the risk of toxicity, it's all about the dose. And dose isn't as simple as just how much. It's this precise recipe of 4 key things: the concentration of the oxygen, the pressure it's delivered at, the duration, how long the exposure is, and the frequency of the sessions. All medical protocols are designed to keep that total dose inside carefully researched, safe biological limits.
So once you understand these two totally separate risks, fire on the outside, toxicity on the inside, you can start to see the logic behind all the safety controls. The long lists of rules you see aren't just random. They're all direct, logical answers designed to stop the conditions for risk from ever showing up in the first place.
Let's walk through the logic here with a really practical example. First, you identify a risk. Okay, static from synthetic clothes can be an ignition source. Got it. Second, you make a rule to deal with that directly. Simple. Only 100% cotton clothing allowed, because it makes way less static. And third, you get your result. You've taken one more variable off the table. You've removed a potential problem.
And really, that's the whole philosophy right there. Effective safety management with medical oxygen is proactive, not reactive. It's all about building an environment where the chance for problems to pop up has been systematically engineered right out of the equation, from the very start.
And that proactive way of thinking brings us to our last point. Safety isn't about a single piece of hardware. It's not about just the chamber. It's achieved through an entire integrated system.
You see, a hyperbaric chamber by itself, it's just a piece of hardware. The therapy itself, the safety, that's a system. And that system includes precise controls for pressure, special ways of handling oxygen, really deliberate time planning, constant human supervision, and safety procedures that are practiced over and over. All of these parts work together to hold clear, non-negotiable limits.
And this quote, man, it just nails the whole idea of medical safety. Think about it. No effective medical procedure is completely free of risk. Anesthesia has risks, surgery has risks, hyperbaric oxygen therapy is just the same. Its safety doesn't come from a magical absence of danger, it comes from the meticulous, unwavering control of that danger.
So we kind of end up back where we started, but now with a totally new way of looking at it. The question isn't just, is oxygen safe? The real question is oxygen safe only when we understand its dual nature and respect its boundaries? The answer is pretty clear. Its safety isn't just something oxygen has. It's a direct result of a system built on structure, supervision, and control. That's what makes its safe application possible. And because of that careful control, different designs can exist for different contexts, always under appropriate supervision.
To continue learning, explore the HBOT Journal channel.